Hello students, in today's class we'll be studying about ionic bonds. Now there are various bonds which help two different atoms combine together and form a molecule or a compound. So if I have an atom over here and if I have another atom over here, both of this will form a bond, and this form, the bond which is formed by these atoms, leads to the formation of a molecule or basically a compound. For example, water. Water is nothing but H2O. Oxygen is one atom, hydrogen is another atom, and I have another hydrogen over here as well. So this atom and this atom will first form a bond, then the oxygen will form a bond with the hydrogen over here. So with this, two bonds are being formed, and this becomes the compound water. In the same way, we have NaCl. NaCl. Just join the bond over here. When you join the bond, what is happening? This is one atom. This is another atom. Both of them are connected by a bond. Now, we are going to study ionic bonding in this particular topic, wherein the atoms basically form ions clubbed together. So there are many types of chemical bonds and forces that bind molecules together. The two most basic types of bonds are characterized as either ionic or covalent. In ionic bonding, atoms transfer electrons to each other. Ionic bonds require at least one electron donor and one electron acceptor. In contrast, atoms with the same electronegativity share electrons in covalent bonds because neither atom preferentially attacks or repels the shared electron. Now let us first see the difference between atoms and ions. Now atoms are nothing but normal elements, one atom of a normal element which has no charge. For example, this is a sodium atom and this is a chlorine atom. Ions are nothing but atoms which have a charge. So this is a sodium ion, a positive charge. This is a chlorine ion, a negative charge. A positively charged ion is known as a cation. A negatively charged ion is known as an anion. Cation is formed when an atom gives away electron. Anion is formed when an atom accepts an electron. So when I make NaCl, Na gives away the electron to form Na plus, and Cl accepts the electron. Which electron will Cl accept? This particular electron which Na is giving away to form Cl minus. So Na plus Cl minus, this plus and minus cancel off, giving me NaCl, which is nothing but my common salt, the salt which we use in our food. Ionic bonding is the complete transfer of valence electrons between atoms. It is a type of chemical bond that generates two oppositely charged ions. In ionic bonds, the metal lose electrons to become positively charged cations, the way I showed you in sodium, whereas the non-metals accept the electrons to become negatively charged anions, the way I showed chlorine. Ionic bonds require an electron donor, often a metal, and an electron acceptor, often a non-metal. Ionic bonding is observed because metals have few electrons in the outermost orbits. By losing those electrons, these metals can achieve noble gas configurations and satisfy the octet rule. So for example, if we see sodium, sodium has 11 electrons. So what will be the electronic configuration? 2, 8, 1. So if it gives away this one electron, what will be the electronic configuration of Na plus? It it will be 2, 8, and 8 is nothing but a complete octet. In the same way for chlorine, how many electrons does chlorine have? 17 electrons. So what will be the configuration? 2, 8, 7. So now what will chlorine do? Chlorine will accept 1 electron to this 7. To become Cl minus, it will become 2, 8, 8. Again, 8 electrons in the outermost shell, making it a perfect octet. In ionic bonding, more than 1 electron can be donated or received to get the octet rule. The charges on the anion and cation correspond to the number of electrons donated or received. In ionic bonds, the net charge of the compound must always be 0. So Na plus and Cl minus. So what will happen if I have Na plus Cl minus? The plus and the minus will cancel off. The net charge on the compound will be 0, NaCl. The sodium molecule donates the lone electron and the chlorine will receive it. And both of them will achieve the configuration. Which configuration? The octet configuration. This chlorine atom receives 1 electron to get the octet configuration. The predicted overall energy of the ionic bonding process, which includes the ionization energy of metals and electron affinity of the nonmetals, is usually positive, indicating that the reaction is endothermic and unfavorable. However, this reaction is highly favorable because of the electrostatic attraction between the particles. At the ideal interatomic distance, attraction between these particles releases enough energy to facilitate the entire reaction. So the entire reaction takes place properly. Most ionic compounds tend to dissociate in polar solvents because they are often polar in nature. The phenomena is due to the opposite charges of the ions. So you'll have Na plus and Cl minus. So you'll have a polar nature, a positive sign, bond, and a negative sign. So this becomes my pole over here. So these are polar in nature. Over here also, we have the example of chloride salts. The Na and the Cl became Na plus and Cl minus. Sodium chloride, it's a chloride salt. Then you have another example, MgCl2. Mg will give away 2 electrons. Chlorine will take in 1 electron. So you have MgCl2. So what is it? Mg is giving away 2 electrons. If Mg is giving away 2 electrons, Mg is 2 plus. 2 Cls are taking 1 electron. So Cl is 1 minus. These are the bonds which are formed. So if we see, we'll have a pole, plus and minus. Over here also we'll have a pole, plus and minus. So both of them are nothing but 2 poles. So with ionic bonds are also known as polar bonds, because when we consider ionic bonds, with ionic bonds we have the equation of forming poles, a positive pole and a negative pole. So with this, we understand what exactly is ionic bonding. Thank you.